Hi, I'm Adam. Welcome back to Godot Game Lab. In this episode, we'll add items to the game which you can combine and equip on units and get all kinds of cool bonuses with them. So for example, if we start the game and just slap in 2 robins, you'll see that we have these gloves which provide an attack speed bonus. So we have a tier 2 robin which should attack faster than a tier 1 robin, but if I slap these gloves on the tier 1 robin, it's set to a crazy high value. So you can see how fast he starts shooting, right? The other robin attacks like a slowpoke, but equipping those gloves means you start attacking like crazy. Another thing you can do is you can combine items. So if I buy a Bjorn and look for a couple other Bjorns as well, maybe to get a tier 2 version, I can slap on a ring which increases the attack power of the unit, in this case the swing ability for Bjorn. But if I slap in 2 rings, they will combine into a new item called RingRing, which provides a huge boost of AP, 13 AP, and launches a fireball at a random enemy when the combat begins. So if we start battling, you can see that this fireball already damaged the zombie before Bjorn even started attacking. But now when we cast the ability, you'll see that it does this crazy amount of damage because the ability power of Bjorn influences how much damage the ability deals. This is a pretty big milestone and we have to do a lot of stuff, so let's jump straight into it. Let's start with the architecture first. I decided to split the new stuff into 3 different categories. The first one will be the new data we introduced to the project. The second one will be the new scenes. And the last one will be the new components or custom nodes depending on how we call them. If you remember, the main difference between the two is that components are general purpose and reusable across multiple projects, while custom nodes also serve a singular purpose, but they are specific to this AutoBattler game. Now let's view all the 3 different categories together first. And in terms of data, we'll introduce the new item resource. On top of that, we'll have the item recipe. And the reason why we need this is because in most AutoBattler games, 2 different items can be combined into a new, stronger one. Item recipes are also resources with 3 export variables, the 2 source items we need, and the resulting item we get from combining them. And finally, we'll have the highest level resource, which we only need 1 of in the project, and that is called ItemDB or database, which will contain all the different recipes we have for this game. Now, in terms of scenes, we'll have 1 scene called BenchItem, which represents 1 specific item that we currently possess and can drag over our own units. We'll also have BenchItems, which will be sort of a container node in the game where we store all the currently possessed items in. It's like an array of items that we can drag onto the units. And of course, this container or parent for the bench items will be stored inside the arena scene in the game. If you notice, I've used a yellow font color to indicate new stuff and a white color for the already existing things we have. Now, in terms of components, we'll have a new one called ItemHandler, and this will be a custom node rather than a component because it's very specific to this game. It will be used to handle anything that's item related, and this will be attached to each and every battle unit so we can keep track of the currently equipped items that unit has. You can see that this is quite a lot of new stuff we want to add to the project, so let's look at the relationship between them for a second, right? So in terms of data and scenes, we'll have the bench item, and the bench item will be assigned an item resource so we know which item that bench item scene represents. Pretty straightforward stuff, right? In terms of data versus components or custom nodes, things are a bit more complicated. So we'll have the battle handler, right, which has access to all the battle units that are currently on the board, and all battle units and units as well will have an item handler custom node attached to them. And this item handler will have an export variable for the ItemDB, the whole database of items in the game. Why do you think we need this? Well, the reason why is that the item handler needs to handle when we drag a new item on top of a unit or a battle unit, right? And what this means is a lot of stuff regarding gameplay, but one of those things is that you need to handle combining items into new ones, right? So the item handler is quite a central part of this whole system, as we need to handle equipping items, combining them into the new ones, and we have this information available in the database with all the recipes. We need to handle how the whole item ecosystem changes when we add or remove an item from a unit, while also providing the bonuses that the items describe, right? And we have to keep track of this for every unit and battle unit in the game. So this is just an example diagram because equipping items is tricky business. I've included the battle unit here, which does feel a bit weird because you might say that, hey, we usually equip items during the planning phase, right? Not during battles. And yes, we do, but there's an edge case in AutoBattlers or a strategy that you can use, and that is equipping items mid-battle. Now that is tricky because we have different units representing units in the planning phase and battle units representing the battling units, but essentially they need to share the same item pool. So when we equip an item that increases the attack speed of the unit mid-battle, when the battle's over, we expect that item still present on the unit as well, right? So that means that this item handler needs to be attached both to the battle unit and the unit as well. So my point here is that this is quite a complex thing that we need to think about. This is just an example diagram and overview how these things relate to each other, but the reality is a bit more complex than that. Now we could keep drawing diagrams, but I just wanted to include two important questions at the end of it that we need to answer when we implement the system. And we already talked about one of these two questions, like what happens when we add items in battles? And the answer is that we immediately should get a bonus, and we expect that item to be still present on the unit after the battle concludes. Now, another interesting thing is selling units, right? We have the SellPortal, and we already implemented getting back the gold from selling those units. But the thing is, we also need to get back the items from the units when we sell them, right? So we need to think about that interaction as well. How can we give those items back when we sell a unit to that BenchItems container? Now we could keep drawing diagrams, but my point with the diagrams is sort of to help you visualize the new bits and pieces we'll implement and how they relate to each other in some cases. But we'll get to the specifics anyway when we implement them, right? So let's just get started and we'll talk about every single detail. Before we jump into the project, I just wanted to very quickly mention that we need to add 2 new sprites to the game at this stage. To implement the new features, we have item background.png in the assets folder. And also if we go to effects projectiles, we have fireball.png. So please download these 2 images, the link will be in the description, and add them to your assets folder. So when we create those new systems, you have access to these images. So I got my project open here and I have expanded my assets folder and we have sprites within that subdirectory. And I'll just drag over fireball.png in the effects projectiles folder. So if we expand it now, I have this image. And with the sprites folder selected, I'll drag over item background.png and this will be added too. So the first thing we'll do is adding the data, right? So we'll start from the bottom and move all the way up to the ItemDB. With the file system doc, let's collapse the assets folder for now. Go to data, right click on this folder, create new folder, and let's call it items. Click on OK or press enter. Select that folder, right click on it, create a new script. And we'll call this item.gd and inherit not from the node, but from the resource class. Click on create, expand the folder and double click on it to open it up in the script editor. Now this will be a pretty straightforward data class to do. First thing we do is we create a new class name called item. Then we'll provide a bunch of export variables. So all items will have a name, which is a string, an ID, which is a string name. The difference between the string and the string name is that string names are immutable, meaning that they cannot be changed after setting them. And this makes them a lot faster, especially when we compare them to strings. It's a small performance gain, but it also like a semantic thing in a sense, because we say that an ID shouldn't be changed, right? So we can use string names for that. Then we'll have a description. I've used export multiline here, so it can be longer than the usual string box we have in the inspector. We'll also have a Boolean toggle to set if that item is a component, meaning that it can be used with another component to combine the two or not. So combined items are not components because they cannot be used for further combinations. I've used the vector 2i for the sprite coordinates because we have a sprite sheet for all the items. And finally, we have a dictionary where the keys will be modifier types. and the values will be modifier values, because essentially all items will provide one or more modifiers, right? So let's say we have a component item that boosts attack speed, right? Then it will have one modifier that boosts your attack speed. Another component item might have a health modifier, meaning boosting your maximum health. But if you combine the two, then you no longer have a component item and you might have multiple modifiers, right? Because from the combined item, we expect it to both raise our max HP and our attack speed as well. Then we'll have a member variable called equipIndex. And this will be used to keep track of the equipped item in terms of which slot does it fill on the unit or the battle unit. And this is important because for the items, we have to generate a unique ID, and the item slot positions can be used inside the unit to generate this unique ID. We'll have one method called apply modifiers. We pass the battle unit as a parameter, and what we do is we loop through all the keys in our modifiers dictionary, grab the corresponding unit modifier, grab the modifier value that we stored inside the dictionary, set its source property to a unique ID that belongs to this item, but we are yet to implement this method, and when we are done with that, we can call unit modifier.addNewValue to add that new modifier to that unit. We'll also have a method called apply bonus effect, and this is an empty method for now, because not all items have to override this method. This will be used when combined items provide some sort of additional bonus for the battle units. For example, in this demo, we use ring, which boosts a unit's attack power, which can be combined with another ring to RingRing. And the bonus that you get from the combined item is that you shoot a fireball projectile when the combat begins. And the logic for that needs to be implemented for that specific item within this method. We provide this interface so the battle handler can call this apply bonus effect when the battle begins. We'll also have a remove modifiers method, which is sort of the opposite of the apply modifiers. And we need this because it can happen that an item gets removed from a unit. When do you think that can happen? Well, think about this. We start a battle and Bjorn has a ring item equipped, right? We see that we are losing that battle, so we decide to slap another ring on that Bjorn, which means that the two items should be combined into RingRing, right? And what this means is that the old ring will no longer be there, so we need to remove the modifier that it provided and replace it with the modifier from the combined item, which is RingRing. And the way we do this is the opposite of what we did with the apply modifiers. We loop through all the modifiers for this item, grab the battle unit's modifier handler, and get that modifier and remove that value where we match the unique ID this item has. Again, we are yet to implement that method, but we can do it now. It's pretty simple. We just return a string and we'll use string templating to make it easier. So what we'll do is we'll use the ID, which if you remember is an export variable for a string name, put an underscore after it and use the equip index to make sure that it's unique even if we have multiple RingRings, right? Then it would be RingRing 0, RingRing 1, and RingRing 2. That is super important so we can distinguish them, because in AutoBattlers usually you can stack multiple combined items for a unit. And the final thing we do is for testing purposes or debugging purposes mainly, we can override the toString method, so we have a string representation of an item resource. And what we'll do is we'll just print out the name, the unique ID, and the description of that item. And that's about it. Hopefully it's not too bad. We can save this with Ctrl S. And if we go back to the file system doc, we can go one level above this. And the next level, if you remember, is the ItemRecipe. So let's right click on this folder again, create a new script. We'll call this item_recipe. And again, we'll inherit from the resource class. Click on create, double click to open it up. And let's see what we need to do here. Now, this will be pretty simple as well. We just need to think a bit about the logic. We'll provide a custom class name called ItemRecipe. We'll need 3 export variables, and all of those are items actually. For each recipe, we have 2 source items and the resulting item when we combine them. We'll provide a really handy method called canBeCombined, and we need two items to decide if we can combine them or not for this recipe, and we return a boolean, right? So what are the cases here? Well, it can happen that the first item we provide as a parameter matches the export variable that we have for a source item, and the second one can do the same, right? See, the problem is this is not enough to decide whether these two items can be combined. Why? Well, if I have a recipe, when I combine a sword and a ring, I have two possible orders for this, right? So item 1 can be a sword and item 2 can be a ring, or item 1 can be a ring and item 2 can be a sword. Now, we could just say that, okay, yeah, I'll just do two recipes for this with the two variations, right? So the source item will be the sword in the first case, and the ring will be 2, and I'll do a ring for source item 1 and sword for source item 2, and the result will be the same. Now, yeah, this works, but it's kind of janky and tedious, right? So for all the combinations, I need to add them twice. It's just too much labor for nothing, and it's easy to mess up as well. So what we'll do instead is we handle this by code to make sure that the order doesn't matter. So we can have these two matches, or we can have cross matches, right? When source item 1's ID is equal to item 2's ID, and source item 2's ID is equal to item 1 ID, right? So in this case, if we define the recipe as sword and ring, if I pass in sword and ring, then match 1 and match 2 will be true. But if I provide ring and sword, then cross match 1 and cross match 2 will be true. If I provide anything else, then at least one of them will be false, so I know that I have no valid combination for this recipe. So with these 4 pieces of information, we can for sure decide whether this recipe can be combined or not by saying that match 1 and match 2 is true, or cross match 1 and cross match 2 is true, right? So we can easily handle this by code, and we don't need to have duplicate recipes. Now, another handy function that we can provide is to get the other source item when we already have an item for a recipe. And this is useful because think about what happens when we drag the second item from the recipe over the unit. We'll emit a signal or somehow call a function, right, where we pass in the second component as a parameter. Just to use the same example as we did before, right? I have a ring equipped, and I'll drag the sword over the unit. Now what happens is that the ring, which I already had, should be removed with all the bonuses, right? Because I combined the two into this new non-component item. So it's true that I currently equipped the sword, but anyway, I need the ring as well because I need to remove the bonuses it provides before I can apply the new bonus, the bigger bonus from the combined item. So what we do is we provide this utility function for this, and we pass in an item as a parameter, and we see whether that matches the first or the second source item from the recipe and return the other one. So in this case, ring would be source item 1 and sword would be source item 2. So if I combine the sword, right, then source item 2's ID will match the item's ID, so I return source item 1, which is the ring. So we just return the opposite one, right? And just as a safeguard, we return null if the item's ID matches neither of these. But that should never happen, because I only need to do this when two components can be combined into a new one. And that's about it for the item recipe. Hopefully it's not too bad. We just need to save this with Ctrl S, go back to the file system, and create the last one. So right click on the items folder again, create a new script, and we'll call this item_db. And one more time we inherit from the resource class, click on create and double click to open it up in the script editor. And this resource will be used to keep track all the recipes that are available inside the game. So we'll provide a custom class name called ItemDB. Then we have one export variable for all the recipes that are available inside the whole game, and this will be an array of item recipe resources, of course. Now we just need to provide some methods to get the recipes when we need them. And we really need only one method for that, because the case is, inside the game, is that we have an array of already equipped items for all the units. It might be empty, but it might not be, right? So we have the already equipped items, which is an array of items, and we equip the new item, which is an item resource too. And we want to return an item recipe, possibly, when we equipped that new item. And that method does exactly that. What we first need to do is take that array of equipped items and filter them through, so we only look through the items that are actually components, because we can skip the already combined items, right? They cannot be used for new combinations. And we are yet to do that method. Then we need a safeguard. So if the new item that we equipped is not a component, meaning that it's already a combined item, or the filtered component is an empty array, we can return null. In both cases, we can combine a new item, right? Because if the new item is not a component, we just need to slap it on the unit and we're done. That won't yield a new recipe, right? And also, if the new item is a ring or a sword, which is a component on its own, but there are no other components currently on the unit, meaning that the components array is empty, then we cannot combine anything either. But if we can, what we'll do is we'll grab the first component from the array of components and the new item and call a method which we are yet to implement again, which will grab the recipe for those two component items. Pretty straightforward stuff. Now, how do we filter through the items of a unit and only get the components? This is pretty easy as well. We call items.filter or array.filter and pass in an anonymous function which returns Boolean. We know that each of these items inside the array are item resources. If for whatever reason we have a non-item, an invalid value inside that array, a null value for example, then we can return false, because if we have null instead of an item, it's for sure not a component. Otherwise, we can return the item resources component property, which is a Boolean, right? It will be true for components and false for combined items. And that will safely filter through this array of items. Now we just need to implement grabbing the recipe, and this is pretty easy as well. We have those two items that we want to combine into a recipe, and since we have an export variable with all the recipes inside the game, we can just loop through them and call that can be combined method we just created, right? Pass in both items, and if it returns true, it means that we can use item 1 and item 2 to get the recipe, so we can return that. And for whatever reason, just as a safeguard, if we don't have anything in the recipes, we return null, which shouldn't happen, by the way, because all two components should have a recipe in the game. But anyway, we return null if for whatever reason we cannot find a recipe. And that's it from the data side. We can save this with Control S. And I think it's a pretty straightforward and clean separation of concerns with the items. Now we just need to actually add item resources to the game, because we created all the scripts for these resources, but there are no resources created yet. So that's what we'll do next. For the sake of the demo, I won't be creating tens of items, but if you want to for your own game, just go ham and create as many items as you want now. To keep it relatively straightforward, I'll do 3 items and 1 combined item. Okay, so let's right click on the items folder, create a new resource, search for item, press enter or click on create, and I'll call this gloves. Press enter again, double click on the resource to open it up in the inspector. Now for the name, we can just use gloves. For the ID, you'll see this @ here. It is used to indicate that this is a string name. So we'll use gloves with lowercase here. For the description, I just say plus 10% attack speed. This will be a component, so let's take this Boolean and also add the modifier. So again, this is pretty easy to mess up, and I always forget to do it. It's not enough to just fill these. You have to click this add key value pair when you're finished, okay? So we'll do, for the key, we'll do unit attack speed. And for the modifier value, we'll use a new value. And this will be a percentage base, and the percentage value will be minus 0.1 for 10%. And we could fill in the source, but we don't need to, because if you remember, each item will have a unique ID, and we set this from code with this line of code here, right? So we can set it in the inspector, but there's really no need to do it, because we'll do this from code anyway. So with the modifier value done, let's not forget to click on add key value pair. And now we have this here, right? So it was a bit confusing to me at first, because you immediately have this new key, new value, but we have above that the already existing modifier. And just to make sure, on the resource, check local to scene to make sure that each item on each equipped unit will be different, right? Or duplicated. Okay, so we have the gloves now, but we also need the sprite coordinates. So if we scroll back in our file system, in our assets folder and sprites, we have items.png. And this is a pretty small image to look at. So if we click on the plus sign to create a new scene, we'll have to do the bench items anyway. Right now, we just add peg sprite 2D. If we go back to 2D view, we can load, quick load for the texture, the items.png. And now it's much better to see. We have a lot of items here. And for the coordinates, we can start counting or experimenting. We have the gloves here. So this is row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But we start the counting from 0, so it should be 13. And we can use, I like the brown gloves here, which is the second one. So the coordinates should be 1 and 13. Now, you see that nothing happens because we need to enable regioning on that sprite. We enable this. We'll set the width and the height to 32 by 32. And if you change it, you'll see we have the coordinates for the gloves. Awesome. So if we press Ctrl P and search for gloves.tres again, we can change the coordinates. If we don't want to type, we can reselect the peg sprite, right click on this and copy value. Press Ctrl P again, edit the gloves, right click on the sprite coordinates and paste the value here as well, just to show you a couple of tricks. Now we can collapse the assets folder because we can use this new scene to get the icons that we want. And with the gloves done, we can right click on the item folder again, create a new resource. Item is fine. And let's do the ring next. So ring.tres, double click on it. The name will be ring, ID will be ring as well. It's a component. For the description, we'll add +5 flat AP. It will be local to scene. And for the modifiers, we can add unit AP and the new modifier value for a flat value of 5. Add that key value pair. It appears here as unit AP. And we need to look at the sprite coordinates. If we click on edit region, we see all these items here. And for the ring, I'll just use this golden one. And for the RingRing, we'll use the big one with a diamond. So this one would be above the gloves 1, 2, 3, 4 times. So this would be, I believe, 17 and 1. We can copy that value and paste it for the sprite coordinates. Right click on the items folder again and create our final resource. This is an item, call it sword. Double click on it. It will be called sword. The description will say +480. It's a component. It gets us a unit AD modifier. The modifier value will be a flat one for 4. Add the key value pair. It appears here. And we set it to local to scene. Now for the coordinates, we'll edit the region. We can pick whatever we want. The swords are at the very top. I just use this basic one maybe. So that would be 0 on the X and 1 on the Y, I believe. 0, 1. Yep. So we can either copy paste it or just type it as 0, 1. And we have the 3 base items ready to go. Now we also need the combined item, which is RingRing. So let's right click one more time, create a new resource. It's an item again. We'll call it RingRing. Double click on it, fill in the information. And I just use an underscore for this. For the description, we set a longer one so it provides more AP. And at the beginning of the combat, it launches a 10 damage fireball at a random enemy. Now, this is for sure not a component, but we need to add the modifiers again because it provides 13 AP. So unit AP, new modifier value, flat one, 13, add it as a key value pair, make it local to scene, and we need to set the coordinates too. So let's look at those rings again, edit region. And I like this one, the green one, which will be the same row, but 17, but at 0 on the X. But we need to double check it, so it would be 17 and 0, right? Yeah. Okay, so let's make this 17 on the Y and 0 on the X. Now this needs to have its own script because right now it's item.gd, but if you remember item.gd, we have this apply bonus effect method, which is empty. And for this one, we need it to be not empty, but this is the very final thing we want to do in this episode. So we'll just get back to this. Now we have all the items ready. What else do we need? We need to have an ItemDB. So let's create a new resource one more time, but this time it will be an ItemDB. We can call it ItemDB as well. And we don't need to create separate resources for the recipes. We can just create them inline in this inspector panel here. Having 3 items would mean that we have 6 possible combinations, right? So let's do them. We have 6 recipes here. Again, I only created RingRing, so all the other combinations will throw errors in the game, but for sure you can go ahead and create your own combination of items if you wanted to. Right now, we just create new item recipes for each and every slot in the game. And we need to create all the combinations, right? So source item 1 could be ring, and we can combine a ring with a sword. Again, I'll leave the result in empty because I don't want to waste more time creating those items, but you would put magic sword or something like this here if you had those. Then the second one will be combining a ring with the gloves. And again, this would be, I don't know, jewel gloves or jewel gauntlet, I believe, is the one we have in TFT. And finally, we have the third recipe, which would be a ring combined with another ring. And this time we do have the resulting item, which will be RingRing, right? So I just want to show you one working example of this and not waste any more time. Now, the reason why we have less and less recipes is because we have some combinations and we don't have to do them vice versa because we eliminated the need for that in code. So when we choose our starting item as gloves, we don't need to put gloves and ring again because we already have that up here, right? So we can just do gloves and sword because that one we don't have yet. That would be something else. And we also need to have gloves with gloves, right? With itself. And that would be double gloves or something like that. And the final one we need is sword with sword because sword and gloves is already there and sword and ring is already there. So for the final item, we only need sword with sword. So in a game with 3 items, these are all the possible combinations that we have. Pretty straightforward stuff. Again, a lot of the resulting items are missing because I want to save some time. So now we have our ItemDB and the recipes are sort of built into it, so we only needed this one resource. And that's about it for the data. That wraps up the data part of this new milestone. We can move on to creating the scenes next. Now, since we already started a new scene for checking the sprite coordinates, why don't we go ahead and create that bench item scene next? So let's click on the plus sign here or press Ctrl A to add a new node. And we'll add an area 2D because we need to drag those items around in the game, right? See, the problem is we actually need that area 2D to be the root of the scene, not the peg sprite 2D, but it's not a problem. We can just right click on this and click on make scene root. So they will swap places and we can double click and rename this to bench item. Now we need to set up a bunch of stuff on this area 2D. First of all, we have monitoring and monitorable flags. And we actually don't really care about other units seeing that we hover over them, so monitorable can be turned off. And if we expand collision under collision object 2D, we have our collision layers, right? We have player, enemy, player range, and enemy range, and we can put items on their separate layer. So let's put it on layer 5, which is just called layer 5 for now. But to keep things tidy, let's right click on it and rename this layer to items. Now, if we hover over it, it will say items, and we want to collide with the player layer, so that's perfectly fine. And under input, we make sure that pickable is toggled on. So that's all we really need from the root node, but you see that we have a warning message because we don't have the collision shape yet. So let's first of all select the bench item again and press Ctrl A or click on the plus sign and add a new sprite 2D for the background of this item. We can drag this above the peg sprite 2D to make sure that it appears behind it. And for the texture, we can quick load the new image we added called item background.png. You see, it immediately looks a lot better. And we can actually lock this. We don't have to move it. We can lock the peg sprite 2D as well. And now we can select the bench item again to make sure that warning disappears. Press Ctrl A again and search for collision shape 2D. We can drag it between the two so we can see sort of the interaction size that we have for drag and dropping and add a new rectangle 2D, for example. Click on it and we could change the size, but I kind of like the default size. If we want to make sure that it's easier to drag, we can expand it, but we should toggle grid snapping off, otherwise it will be hard to interact with. So we can make it a bit bigger and we'll see how dragging it feels later on. We can toggle grids back. And really the final thing we need here is to add a drag and drop system to this. But fortunately for us, we already have a drag and drop component. And this kind of showcases the power of using components to build games. You can just press Ctrl A on the bench item again and search for drag and drop. And you see it's enabled by default and we need to have a target which is in area 2D. We just click on assign and assign the bench item. So now if we save this, we don't even have any new scripts, but if we save this and go back to our scenes folder, create a new one called bench item, save it as a TSC and bench item is fine. And if we run this scene on its own with F6 or clicking on this button, you'll see I can already start drag and dropping that item around. And if I release it, it stays there. So that's what's so cool about the drag and drop system we created. We can just plug and play, right? Add it as a node, set up the export variables, and now this has drag and drop. Pretty awesome stuff. But of course we do need scripts because we need to handle what happens when we drag and drop. And we also need to update this PegSprite 2D based on the item resource that we attach to that bench item. So let's select the root node, click on the plus sign here to attach a new script, and benchitem.gd is perfectly fine. Click on create and let's see what we need to do here. And promise this will be pretty straightforward as well. Now I made this a tool script to make sure that when we use the editor and update the item resource, the representation in the PegSprite 2D updates as well. The class name we use will be benchItem, and we'll have one export variable for the item resource, and we'll have a custom setter function for it. We'll also have two already variable references, one to the drag and drop component and one to the PegSprite 2D to update that visual representation. And we'll also have a member variable to keep track of the hovered unit for the item. It will either be null if the item is not hovering over any units, or a reference to the unit that it hovers over. Now inside the ready callback, what we do is check if we are inside the game. The only thing we want to do if we are inside the editor with the tool script is actually updating the icon. All the other things or logic we need to execute when we are actually playing the game. And that is connecting two callback methods to the area entered and exited signals, and also to the drag canceled and dropped signals to the drag and drop component. Of course, we are yet to implement any of those methods. And the final piece of code that we include is item equals item, which sounds a bit weird, but we only include this line for testing purposes, and I'll explain why when we are testing the game. But basically the gist of it is that we want to trigger the setter function to make sure that it updates the icon for the item when we test it. Now the custom setter function looks like this. First we update the item property to the new item resource. And if the new item we set it is null, or the drag and drop component is not yet instanced in the game, we return from this method because it means that the scene tree is still being built and we cannot update the PegSprite 2D yet. But if it is ready, we set the coordinates property of the PegSprite 2D component to the sprite coordinates found inside the resource. Now onto those callback methods. So when we enter a new area 2D, we need to check, just for safety, that the area that we hovered over with the item is a unit or a battle unit. In both cases, we update that member variable that we have to keep track of the currently hovered unit. Exiting the area is kind of the opposite. So when an area exits, we set the hovered unit to null. Canceling the drag is pretty straightforward. We set the bench item's global position to the starting position of the whole dragging mechanic. And actually dropping the item has two different cases. So if we have a hovered unit when we dropped the item, it means that the item should be equipped on that unit, right? So what I did here is a debug print message that the item is dropped over this unit, and it should be equipped when we have the item handler, and we can queue free the bench item itself because it will be equipped and it's no longer needed to be visually present. But if we don't have a legit hovered unit when we drop the item, then we need to reset it to the dragging starting position, right? Which is a slot on the bench where we have our items. Pretty straightforward stuff, right? Like 50 lines of code, it's not too bad. And that's enough to test this. So if we save the script with Ctrl S and go back to 2D view, what we can do is we can change this item so it should update the icons. So if we press quick load here and search for gloves, well, nothing happens. So I presume we need to save the scene with Control S and reload the current project. And if we reset the item and quick load it again, it should update now, yeah. So we have the gloves here. Awesome. Now, let's see if we can test this in-game, right? In isolation, we know that we can drag and drop it. The only thing that we can test if we press F6 or click on this icon is that if I drag it and I hover over no unit, then it snaps back to its original position. Or if I drag it and press right click to cancel it, it resets back to its original position. And both of those things are working, but we cannot check for the output message of equipping it over a unit. So to do that, let's stop the game for now and go back to our arena scene. And just so we have something with the arena selected, let's click on the instantiate child scene button or press Ctrl+Shift+A and search for bench item. And you see we have this bench item here at the top left corner. Press W to go into move mode and move it a bit further away so it's easier to move. Press Q to go back to selection mode. And for the item, it says item, which is a bit weird because we assigned the gloves to it. But if you think about it, it's not that weird because it's set to local to scene. So what this means is that it created a duplicate of it. But if we click on it, it's still a gloves item. So if we leave it like this and run the arena scene by, I don't know, a couple Robins and Bjorns, we can drag the gloves over an empty space, it snaps back to its position, but if I drop it over Robin, it disappears, and we get an output message that the gloves are dropped on Robin. Awesome, so the bench item is a separate scene, it works completely fine. We can delete this bench item scene from here and save the arena. And the reason why we added that line of code, item equals item, is to make sure that we trigger the setter function to update what we have, and we won't need it in production because items won't be instantiated before the game starts like we added that to the scene tree. They will be instantiated dynamically when the game is running, and with that we have much more control over spawning the item, so we can just set the item property after we spawn the object to make sure that the setter triggers. So we can delete this line of code here as well, save this, and we're done with the bench item. Now we can move on to doing that container scene, which will have the spots for all these bench items to spawn. So let's go back to 2D view. Click on the plus sign to create a new scene, and we'll start from a 2D scene this time. Double click on it and rename it to bench items. Let's save this with Ctrl S to our scenes folder. Create a new folder, call it bench_items. Save it. And what we need to do here is pretty straightforward. I just use marker 2D nodes for the position of slots where we can spawn new items. In this case, or in this example, I'll maximize the number of items that you can hold on your bench to 8. So what we do is we click on the plus sign or press Ctrl+A and search for marker 2D, which helps us with editing. It provides a gizmo. Now we don't really see anything for the first one. You can barely see those arrows, but it will be better for the other ones, I promise. So let's double click on it and rename this to item slot 1 and press Ctrl+D to duplicate it a couple of times. We need 8 together. So select the second one, go into move mode by pressing W, and since I have the grid snapping enabled, I just move it. I can just move it any way I want. It really depends on how you want your items to stack. You can either do it like this, so 1, 2, 3, 4, 5, 6, 7, 8, or you can do it like 1, 2, 3, 4, 5, 6, 7, 8. Use whatever makes more sense to you. I just use this version, so 1, 2, 3, 4, like this. So 3 will be here, 4 will be here, 5 will be here, 6 here, and it makes it really easy to do it with the grid snapping, right? Now you can see it better what the marker 2D does. It sort of just represents a gizmo, and you can see that position in the 2D space better. So these are the slots where we can instantiate our items. And that's about it. It's pretty easy in the scene tree. We just need to add the script to handle that logic as well, spawning the items in. So save this with Ctrl S. And if we're happy with our slots, we can lock the positions, but I don't think there's that big of a chance of accidentally moving them. So let's just select our bench items, our root node now, click on the attach script button and create a new script and see how we can handle spawning those items. First of all, we'll provide a custom class name called BenchItems. And the next thing we want to do is we want to have a reference to our BenchItem scene as a peg scene so we can instantiate them dynamically. Now, if we take a look at our file system doc here and search for bench_item, we have this tscn here. So what we can do is we can drag this over to the editor and press and hold Control while releasing it. And this looks a bit weird at first, but in newer Godot versions, when you preload resources, it uses a unique identifier instead of the path of that resource. And the reason why this is cool and useful is because if you decide that you don't really like the folder structuring of your project, if you were to use the path here like resources, scenes, BenchItem, benchitem.tscn, that would break all the code here, right? Because you have to update the path. But with the introduction of UIDs or unique identifiers, you can just reference that unique ID and it doesn't really matter where it lies in the project hierarchy. Awesome stuff. The next thing we'll do is we'll provide an array of marker 2D nodes for the slots. Now, this could be an export variable and we can set it one by one if we wanted to, but it's much easier to just do this in the ready callback and programmatically assign all those slots from the scene tree. And what this looks like is just iterating through the array of nodes we have with getChildren, and since we know that these are marker 2Ds, we can just append them one by one to this array of item slots. Now we want to make sure that we can actually test this functionality, so we'll provide an array of items and just randomly assign them to the slots, right? Again, we can preload the item resources here. We can either provide the path, it still works, but if we search for items, you can select the folder, clear the search for now, select gloves, press and hold Control, select rings and sword. And with this array here, we can just drag them over, press and hold Control when we release them. And you know, it's not the best because if you take a look at the code, it provides those as constants, but we can just delete the constant keyword and the assignment before them and just preload the resources themselves. And also not forget to put commas between them as these are members of an array. Now what we can do, and again this is just testing code, is we can iterate through the size of the slots we have and call a method called addItem and pick a random item to add it to a slot. Of course we are yet to implement this method here. But adding an item means this. We get an item resource, we pick the first empty slot from our children, and if we for whatever reason don't have one, then we need to print this message that we have no empty space for an item. This is just a placeholder. It's really up to you how you want to handle this in your game. If you don't want to have any restrictions of the number of items that the player can achieve, then you need to somehow handle this. This version of the demo or this MVP uses this fixed number of slots that we assign from the scene tree. And for now, I don't have any error handling. Probably what would be good here is to show a tooltip pop-up message that your item bench is full or something like that. But otherwise, what we do is we instantiate a new BenchItem scene, add it as a child under the slot, which is the first available slot that we have, and set the item export variable to the item resource that we pass in as a parameter. And that's why I said that we don't really need that extra line of code of item equals item in the BenchItem script, because you see when we call addChild, it will be for sure ready in the scene tree when we set the export variable, so the setter function will be triggered. Now the question is, how do we get the first available slot? But this will be pretty straightforward as well. What we do is we iterate through our array of marker 2Ds and check if the getChild count is equal to 0, because if you remember, all these new bench items will be the child nodes or scenes of a slot. So if a slot has no child yet, then we can return that slot as an empty slot. Otherwise, we return null. And that's why we can trigger this message when the return slot from this method will be null. And that's about it, 30 lines of code. I hope it's not too bad. And much of it is placeholder code anyways. So let's save this with Control S and check if we can test this. So if we go back to 2D view, we can test it in isolation by pressing F6 or clicking on that button. And you see we have a bunch of items assigned to it. We can't really see all of them fully, but we have 8 items with 8 slots, right? And we can drag them over, it snaps back to its original position. But it would be much better to take a look at this in the arena scene, right? So let's go to the arena scene next. Select the arena, the root folder, click on the instantiate child scene button or press Ctrl-Shift-A and search for benchitems.tscn. Now if we add it, you see that all the markers will be added as well. And let's move it up so we keep some sort of order. I'll put it between the bench and the SellPortal. Go into move mode by pressing W and we can find its position. And I kind of like it here, but I'm not sure if I can position this as well as I want to on the grid, because I would like the items to be on this 4x2 table, right? So we can calculate that position. We select the bench items, go to transform, and on the X, we'll add 16, and on the Y, we'll subtract 16, and we get this nice little table looking thing, and we'll see how that looks in game, but I think it will be fine. When we're happy with this position of the bench items scene, we can just click on the lock to make sure we don't accidentally move it. And if we play the game, what should happen is we have 4 random items spawned. And we can just drag them over the units. If we miss a unit, it will be snapped back to its original position. If I hover over a unit but press right click to cancel it, it will also snap back to the original position. And we get all the debug messages that the ring was dropped on those units. Awesome. So that's pretty much what we need to do, at least for now, in terms of new scenes. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. Now, the next thing we want to do is the ItemHandler custom node. If you remember from the architecture overview, what we want to do is to have access to the ItemDB and slap this custom node on the BattleUnit so we can handle equipping items, combining items, applying the modifiers and such. So with our file system doc here, let's scroll all the way up. We can collapse the data folder for now, go to custom nodes, expand that folder, right click on it and create a new script, which we'll call ItemHandler.gd. Click on create or press enter and double click to open it up in the script editor. Okay, so how will that class work? First of all, we'll provide a custom class name called ItemHandler. We'll have 2 signals that we can use throughout the project to interact with this system. One is called ItemRemoved, which is emitted when we remove an item from the unit. And the other one is called ItemsChanged, when the equipped items on the unit has changed. We'll also have a constant called maxItemsHeld, which will make sure that is equal to 3, which is quite common in these games. If you want to make your game more dynamic, you can change this from a constant to a variable that is attached to the unit stats or something like that, so it's dynamically changeable, but for the purpose of the demo, we'll find with the constant being 3. We also need export variables, one reference to the ItemDB so we can know if we need to combine 2 items when we equip them or not. And we'll also have an export variable for the equipped items, which will be an array of items. By default, it will be empty. Now, strictly speaking, this doesn't need to be an export variable, but it would make testing it in isolation much easier because you can just slap items on the units or the ItemHandler in isolation and see how it behaves much easier. In the ready callback, what we'll do is we'll connect ourselves to the ItemsChanged signal and just print out all the equipped items. This is purely for debugging purposes, so we can see whether the ItemHandler works properly or not. The most important public method we need is called addItem, where we pass in an item resource as a parameter and we return a bool, which will indicate whether we can successfully add that item to the ItemHandler or not. And that depends on a lot of stuff. First of all, we need to check if equipping the new item means that we have a recipe that now we can combine with, right? So we use the ItemDB's get recipe for new item, and we'll pass in the equipped items, which is the array of items we have, and the new item that we equip. It might happen that we get a recipe if we have 2 components matching, and in this case we need to combine them and return true because we could successfully add that item. Now, of course, we are yet to implement the combine components method, but we'll do that in a second. Otherwise, we just try to equip the item as is, which will be handled by calling a method called tryEquippingItem. Now, why do you think that we can only try equipping that item, not for sure equip it? Because it might happen that we are already full of items. So if I have 3 items, right, and try to add a new item to it, it might happen that I don't have a recipe for it because it's just 1 component. But I can be sure that I can equip it because it might happen that I'm already full of items as a unit. Now all that's left to do is actually implementing those methods, right? Well, yes, but we also need a couple of helper methods. So we'll have one for removing an item at a specific index. Now how do we handle this? First, we need to grab the corresponding item on the set index. Then we need to set the array's value at this index to null, indicating that that item was removed from there, and emit the item removed signal while passing in the item resource as a parameter. You'll see why we need that in a second. Besides that, we'll also have another public method which we won't use yet, but it will be really handy a bit later on. It's called copyItems2, and it takes in another item handler as a parameter. And what we do is we grab that other item handler and clear the equipped items array of that one, loop through all the equipped items that this handler has, and call the addItem method on the other one, passing in that current item. Now, why on earth do you think we need this? Remember that problem or very specific edge case I was talking about? Let's imagine that I'm in mid-battle with a battle unit. I equip a glove on Robin mid-battle, hoping that this attack speed boost will be enough for me to win the battle. Now if I exit that battle, that Robin unit representing the board between the battles does not have that attack speed boost item equipped to it. And I don't expect as a player that when a battle plays out, if I equip an item, that it will be lost to the void and it won't be present when the battle is over. So what we need to do is we need to make sure that we synchronize the state of equipped items between the units and the battle units. And to do this, what we do is call this method mid-battle, right? When a new item gets equipped to the unit. And we can just copy all the items that the battle unit currently has to the resting unit, right? That we use when the prep stage is on. So this method will be used to make sure that when we equip items mid-battle, the unit and the battle unit scenes will be synchronized in terms of items. Now we can finally implement the two missing private methods, the combine components and the try equipping item ones. Now combining components looks like this. We pass in the recipe and the new item as a parameter, right? So what we do first is we call recipe that get other source item to grab the already equipped component from the unit. And we also need to find the index of it at the equipped items, because when we combine the two together, we expect the new combined item to appear at the same index that the first component was at. And when we've done that, we have a really important line here. First, we have to remove that component item that we had. And this is super important because otherwise we would keep the modifier bonus from the component item and would also on top of it add the combined items bonus. And we don't want that. If I have the ring, which gives 5 AP, which combines it to RingRing, then I need to have one modifier for RingRing, which gives 13 AP. But if we wouldn't remove that item first, then I would keep the 5 AP bonus and add the 13 bonus on top of it, which is unfair, right? That's not how the system should work. So we need to remove that item first, and then at the same index, add the new item, which is the recipe.result, right? The combination of the two, and set the equip index parameter to that same index that we are dealing with. This is also important to make sure that the unique ID that the item generates will be correct. And when we're done with all that, then we can emit the items changed signal because we successfully equipped a combined item in place of the already existing component. Okay. And then we have the final method, which is try equipping item. And remember, this is much simpler, but we need to deal with reaching the maximum size of items. So what we do is we check if the equipped items.size is greater than or equal to the max items held constant. And if it is, then we return false because we have no available item slots. But otherwise, it will be pretty straightforward. We just append the item at the end of the equipped items array. And we also update the equip index of that last item based on the size -1 to make sure that the resources equip index for the unique ID remains updated. Then when we edit that item, we can emit the change signal and return true because we successfully equipped that item. Hopefully it's not that bad, it's 60 lines of code, but it has a lot of thought to it because there are a lot of edge cases we need to handle and think about. I think this is pretty tricky, like removing the item before adding the combined one to make sure that you won't have any remaining bonuses. But otherwise it's hopefully not that bad. And we also have this debug code here so we can test it out as soon as possible. Let's see if it works or not. We can save this with Control S. And if we want to, we can test this in isolation, right? So if we just add a few lines of code in the ready, we can do something like, I don't know, wait 1 second, await get3.create timer 1 timeout, and add an item. And let's say that we want to add in our gloves, for example. Just press and hold Control while dropping it, right, like this. And since we have an export variable for the equipped items, we can check if everything works or not in all the edge cases. So let's save the item handler for now. And to test this, we need to add it to the battle unit and the unit as well. So let's go back to 2D view, press Ctrl-Shift-O and search for battleunit.tscn. Now here we have a bunch of nodes, so I'll make this bigger. Select the battle unit, press Ctrl-A or click on the plus sign and search for item handler. And move this all the way up under flip sprite. And let's make sure that the ItemDB is provided, right? So we have access to the recipe, so quick load our ItemDB resource. And just to make sure that we can use it to actually hook this up, we'll open the script for the battle unit, which is a pretty big one by now. And what we'll do is we'll drag and drop our item handler node while pressing and holding Control and moving it up to its place under flip sprite like so. So we have an already variable reference to it. Save this with Control S, go back to 2D view. And if we run the battle unit scene on its own with F6, we have our unit there. And the output should say item gloves, glove 0, plus 10 attack speed because we equipped the glove, right? Now, another thing we can test if we set the equipped items to something before it. So we can do something like one equipped item and quick load our gloves. Now, if we run the scene again, we get an error message and it says invalid assignment of property or key equip index based on nil. Now, why do you think that is? What happened here? We call the combine components, and if we take a look at our recipe that we want to have is gloves and gloves. And see, the result of that is null. So when we call this method at the equipped items, we'll assign a null value to the array. So the reason why we get this error message is fine. It's not the problem of the system. It's just a problem of my laziness because we said that we don't provide all the combinations for it. But that's not a problem, right? It should combine into 2 gloves, but since we don't have that item provided yet, we don't know if it works or not. So let's just quick load instead our RingRing, and then the error message should disappear. And what should happen is that RingRing stays there as the first item, and as the second item, we'll equip the gloves component. And if we run the scene again, we'll have RingRing here, right? And next to it, we have this comma, item gloves, gloves at 1, attack speed. Awesome, so it does work. It's just that the error message we had, make sure that we cannot really combine them. So if we want to test if the combination works, we can go back to the item handler script. And instead of preloading gloves, we can change this add item to ring instead of gloves. So if we press and hold Control and drag it over, we change the UID to something else. And now if we have one RingRing equipped and run the battle unit scene, you'll see that we'll have a RingRing, it stays there, and we have a ring at the index of 1. And now if we change this and say we have 2 equipped items, a ring and a RingRing, and if we make sure that they swap places as well, so we have a ring equipped at 0 and the RingRing equipped at 1, what happens is this should remain there and this should be combined into RingRing. Run the scene again. What happens is, it's interesting because we only have a ring and a RingRing. So it says, So maybe we just don't have the output yet and it works. We need to check. If we go to the remote scene tree and click on our item handler, you'll see that we have our equipped items array. And if we expand it, we have 2 objects. The first one is a ring and the second one is RingRing. Okay, so for some reason, right, it didn't combine it. So it doesn't work as expected, and that's why it's always a good idea to test this in isolation, right? Now, why didn't it work? After adding the item, let's just add an extra line of code where we print the equipped items to see if it changes anything. So rerun the battle unit again, and it just says it's a ring and -1. and the RingRing at -1, which is awkward because they share the same index, right? So how did we end up equipping at -1 when we already had one? See, the thing is, we equipped these two and we couldn't equip the third one, or rather we override one of these. And the thing is, when we change this equipped items array, it's empty by default, but we added it inside the inspector. In the ItemHandler script, we were very careful with the thing that is keeping an up-to-date index, right? So when we add a new combo or when we try equipping an item, we update the equip indexes as well. But when we actually edit the export variable here, we don't really update the indices. So one thing we can add for the code, if we do want to have pre-equipped items on the units, we could do two things. One of them is just use the add item call like we do here, because this will make sure that whatever we pick, combining them or equipping a new item, then the indices will be updated. But when we just edit the export variable, then they won't be updated on their own. And I would say that it's not a problem because in reality, most of the time you want to equip items dynamically from code anyway. But, in some games like in TFT, usually you can pick a starting unit with an item equipped on it. And if you just want to edit those combinations in the inspector, it might happen. And also in testing, it's much easier to just edit the export variable. So we can just add a line of code here and do for I in equipped items that size. If equipped items at I exists, then we say that equipped items.i's equip index should be equal to I. And this will make sure that if we have any items assigned in the inspector, then when the item handler is initiated, then the equip indices will be updated as well. So now if we save this and press F6, I believe that this should be fixed, right? So the indices are fine because we have, and you see still no, because ring at 0 is fine, but RingRing at -1 is definitely not fine. So let's take a look at this. We have two equipped items in the item handler, one ring and one RingRing. So the size of the array should be 2, and we set the equip index to equal to I. And let's put a print here to see before we change it, we have the correct indices, because that will help a lot. So after we initialize it, let's print it out and run it again with F6. And when we do start the game, we have ring 0 as a ring we already have, and we have RingRing at 1 as an item we already have. And that's absolutely fantastic because that's what we want to do. Now, after we equip another ring, this ring should become a RingRing at 0 and RingRing 1 should stay there. But instead it becomes RingRing -1, which is really odd. So let's see what triggers this behavior. Now, when we go to the add item, we can see if we have a matching recipe, right? So let's print the recipe source item and recipe source item 2 when we combine the two components. Okay, so this is the one that we should be looking at, right? The recipe says that we will have 2 rings. -1 is okay here because they are not equipped anywhere. So we can say that this method correctly returns that we should have 2 rings that can be combined with each other. Now, we have something that is up with the combine components method here, then. Let's see if we can identify the index where we're supposed to find our other source item, which is in this case the ring, right? This should return 0, and we should change the item at index 0. And if we output this, it returns -1. Okay, so for some reason, we cannot find that we already have a ring equipped from this. Let's see if we correctly identify the equipped component that we need to have, right? Because we get the other source item from this one. We press F6. Okay, we identified that we need to find the ring. Cool. So how come equipped items that find cannot really return that equipped component? Well, it turns out that array.find does not work in this case, right? Because the equipped component will be one resource that we get from the recipe with a unique identifier. And the other one that we have equipped might be a different resource because we duplicate them using local to scene. So even though they are both rings, array.find won't treat them as the same resources because we use local scene and they are duplicated. And there are two ways that we can go about this. We either say that we don't really care about always duplicating the item resources in the memory because they will be the same items anyways, right? Always. I would say that this is probably a safe bet for now, but it's hard to tell that in the future, if you were to keep expanding on that project, that would lead to unexpected behavior. You know, by default, resources are shared between instances. And if one instance modifies a resource, all the other instances possessing the same resource would apply those modifications as well. So let's imagine that there's an item or an upgrade on a unit or a trade bonus which doubles all the item bonuses for the units, right? So let's say we have dwarves, and dwarves have this trade bonus that when you equip an item on them, all the bonuses that they provide will be doubled. Now, if you treat the items as non-separate resources, then what happens is that the non-dwarves or even the enemy units equipping the same items would receive the bonus. And I would say that for this demo it would be fine, but you definitely don't want that on a large scale, right? So what other option you have? We can go back to the item resources script by pressing Ctrl+O and searching for item.gd. And here we can provide an alternative method to check if two items match or not. We can provide a static function for this, which receives two item resources and compares their ID. Not their unique ID, mind you, because that depends on the equipped index, but their original ID, which is their name, right? Their string name. So in this case, it would be ring. And if ring equals ring, then we can return that, yeah, these two items are the same regardless of their unique ID in the memory. And for this, I think it makes sense to provide a static method or a static function because this is not tied to an item. Or we can provide that on an item level and say that an item can check itself against another item. Both of these are actually fine. We can just do the item checking itself against the other one. So we can do a function or a method called equals or something like that. And we can pass in another item as an item resource. And we return a boolean, and what we'll do is we'll return self.id equals other item.id. That's about it, right? So this simple change here, if we save this with Ctrl+S and go back to the item handler, we have equipped items.find, which would loop through the array and look for the same item. Now we don't have a method that loops through an array and returns a matching one, but we can implement this in the item as well if we wanted to, or we can just loop through it or provide a helper method here. But if we, for whatever reason, need it elsewhere in the project, I think it makes sense to implement it in the item class as well. And this can definitely be a static function, so we can say static func find item, and we can do items, which is an array of items as a parameter, and also item, which is the item that we're looking for, and we return an integer, and it will behave in a similar fashion that it does for the array.find. We'll just loop through in the items.size, right? And if items at I equals the item we're looking for, then we can return I. And if no matches were found, then we can return -1, indicating that there was no found method like this. If we save this and go back to the item handler, instead of this, we can do item.findItem and do equipped items. And the item we're looking for is the equipped component. So with this change, if we save it with Ctrl+S, we should be good to go. If we test the BattleUnit scene again, let's take a look. We have a ring at 0 and the ring at 1 to begin with. Now we do find the ring at the 0 index, right? And what happens is we combine it and there will be a ring at 0 and there will be a ring at 1. So now the whole handler behaves the way we expect it to. Hopefully this was a useful detour or debugging for you. Now we can remove the print statements, and also if we scroll all the way up, we can remove this print statement as well and this debugging code. And again, we can leave this if we want to as is, but usually we would equip items from code anyway, and then it won't be a problem, but you know, better safe than sorry. So this, if we want to, we can also delete, but for now, I just leave that in and we'll get rid of this later. if we go back to the BattleUnit in 2D view, let's not forget that the item handler should be empty by default, okay? So we already added it to the BattleUnit, and after that whole debugging debacle, we can press Ctrl-Shift-O, and let's not forget that we need to add one to the unit as well. So let's select the unit, press Ctrl-A, add an item handler, drag it up above our drag and drop here, set the ItemDB, quick load the resource, and we can leave the equipped items empty for now. Save this and reference it in the unit's script so we can access it from the outside. Just drag it over, press and hold Control, and use Alt and up arrow to move it above the below base rotation, and save it with Control S. Phew, okay, now we're done with the item handler. The next thing we can do is we can replace the BenchItems placeholder script now. So if we go back to BenchItem, you see what we do when we drop it over is that we print out a message. And this was fine because the units didn't really have an item handler yet, but now we do. So we can replace this placeholder code. And to make this as easy as possible, we replace this whole thing. The first check we do is that we actually have a hovered unit. Now, we either do or we don't. If we do have a hovered unit, we'll grab a reference to the item handler because we know that it's either a unit or a battle unit, and both of those have an item handler. And if the item handler that we grab exists, and we return true for the add item method, because remember we just try to add the new item, we either succeed or we don't. Because if we are already full of items, then we cannot add it. So if we do have an item handler and we can add it, then we can queue free this item, because it means that we successfully attached it to the unit and can return from this method immediately. And if we didn't return, which can mean a couple of things, it can mean that we don't have a hovered unit, but we dropped the item, then we can just reset the global position. It can mean that we do have a hovered unit, but we didn't have access to the item handler, or we couldn't add the item for whatever reason. Maybe the unit is already full of items, and in this case we didn't return either, so by the time we finish this callback, we can reset the starting position again, right? So it handles all the edge cases because basically the only case when we can add this item is if we have a hovered unit and we have an item handler and the add item method returns true. Then we can delete and return. All the other cases, we just reset the item to its original position. Save this with Control S, and if we run the whole game now, we should be able to just add items on different units now. So if I drag over this ring, you know what happens? The change signal gets emitted from our item handler, and it will display that we have an item equipped now. If we drag another ring to Robin, the ring is replaced with the RingRing. So the two items combine into RingRing, and if I drag another ring now, we should have a RingRing at 0 and the ring at 1, right? And I can do this with other units as well. They should have swords, rings, and all that stuff, right? So now equipping the items and combining the items from the bench kind of works. Also, let's run it again because I forgot to show you that we cannot really drag items to anywhere else, right? So nothing happens when I drag it over somewhere where I cannot equip it. Now, we could go many ways continuing this milestone. One of them is actually make sure that the bonuses that the items give get applied to the unit, because yet nothing really happens. This Robin has a RingRing on him, but if I start the battle, no fireball, of course, is there. Also, if I drag a sword on Bjorn, it gets added to it, so Bjorn should have a sword now. But see, since we don't synchronize it yet, I just lost my sword. And if I take a look at the remote scene tree now, select that unit from a list, this one, and the item handler, it only has a ring, but I drag the sword on Bjorn as well. So that sword kind of gets lost in nowhere. That's a problem. But we also provide no bonuses yet. And another thing that's problematic is if I go back to the game's input and I set Robin, remember I had a RingRing attached to him. And now what happens? I just kind of lost my RingRing, right? So we need to update the SellPortal to give back the items when we sell a unit. we need to hook up the bonuses for the items, and we also need to make sure that we synchronize the state between the battle units and the units in terms of items. Let's continue with the SellPortal because I think that's probably the easiest one. Okay, so if we press Ctrl-Alt-O and search for SellPortal, scroll all the way down to selling the unit, you see we have this to-do comment here saying that we should give items back to the item pool. Well, yeah, but how do we do it? Now, since we have the unit that we are selling, units do have an item handler now that we can access, and we have the equipped items available. The problem is, where do we want those equipped items to spawn? Well, if we go back to 2D view, we have our bench items, right? That's where we want to spawn them back, and this bench items also has this method called addItem, right? Which we can use. Now we just need to call that repeatedly for all the equipped items that the unit that we are selling has. And these nodes are adjacent to each other. So the tempting thing to do is to make an export variable reference to our bench items and just call that method. But I don't really think it's the responsibility of the SellPortal to do this. And the way I went with this instead is emitting a signal when a unit is sold and passing in the unit as a parameter. So what we can do if we scroll down, instead of this debug message, is we can just emit the unit sold signal before we delete it with Q3. And now we can connect to this signal with our bench items. But again, we don't really want to make that direct connection between the two. We sort of have the common ancestor, the arena, which can orchestrate this interaction between the two. But we need to provide a way for the bench items to add back items from a sold unit. But this will be pretty straightforward to do here, since we do have our addItem method available, right? So we can do something like this. We'll create a function called return items from unit. We pass in the unit as a parameter, which again will be the parameter of the signal as well. Iterate through all the items in its equipped items array. And if it is a valid item resource, we add it. And that's about it, right? In this case, we kept the separation of concerns, right? There's no direct dependence. The bench items doesn't have a reference to the SellPortal and vice versa. So I feel like this is a cleaner solution. And what we can do is we can make sure that when a unit is sold, this function is called. And we'll do that in the arena, which is responsible for this high-level orchestrating stuff. Here we already do have a reference to the SellPortal, but we don't have one to the bench items yet. So what we do is we drag and drop this over here, press and hold Control, and use the Alt key and up arrow to move this above the SellPortal. And then it's pretty easy to go to the ready callback and just do SellPortal.unitSold.connect bench items that return items from unit. And that's about it. So now we have this connection, and if we run the game with F5, we can get a tier 2 Bjorn or something. And if we drag over a sword to Bjorn, and drag over 2 rings to Robin, and now if I sell Robin, you see a RingRing, the combined item, is spawned back to the bench. If I sell Bjorn, the sword is spawned back to the first available slot. So now we don't lose on items when we sell our units. Pretty awesome. Now comes the hard part. So how do we make sure that all the bonuses will be applied to the battle units that you get from equipped items? And also the question of how do we keep all the things synchronized between the units and the battle units? Now for this one, to make sure that everything's a bit tidier, I just right click on the scripts and close everything up, press Ctrl-Alt-O and search for BattleHandler. Now this is the biggest class that is responsible for orchestrating the battle in our game. Question is, what do we need to do here? Well, we have this part of the code called prepare fight, and we iterate through all the units and the enemy units, right? Now, for the units, we can just do something like this. We have this setup battle unit, we have this add trait bonuses, and we can add something between called add items. And we pass in both the unit and the new battle unit that we spawned. And here we need both because, again, we need to keep this synchronized between the two. Now, of course, we need to implement that method. But while we're at it, one thing that we can also do, if we scroll all the way down, we have this. We turn on the unit navigation, right? We shuffle the battle units and one by one turn on the AI for the units. But here, one thing we can also do is we can loop through the battle units equipped items and call the apply bonus effect method. Now, this is the one-time bonus that we get from equipped items, the more complex ones like RingRing that shoots a fireball when the combat begins. This has nothing to do with the basic modifiers. If we press and hold Ctrl and click on it, you remember this is empty for items by default, and we need to override this with a custom script if we want to do a more complex item logic. But these will be applied at the beginning of the combat. So far, hopefully it makes sense. We do this for one-time bonuses, and when we prepare the units, we also need to do adding the items to them. Now, how do we add items? We have our add trade bonuses method. If we click on it, and above it, we can do the add items method as well. Again, we receive both the unit and the battle unit to make sure that we can keep things synchronized. When we spawn the new battle units, what we do if we disregard the synchronization problems is pretty straightforward. We just grab the units equipped items and add them one by one to the new unit. Or if we want to make this even simpler, we can use that copy to method that we have, right? So we can just do, instead of this, unit.ItemHandler.copy items to and say new unit.ItemHandler, right? That's why we have this. If we press and hold Control and click on this, this is exactly what it does. It loops through the equipped items and adds them one by one and clears the array beforehand. Awesome. So we did this with one line. Now, this would be the only thing we need if we didn't have that synchronization problem. But the problem is we do have that. So what we need to do is we need to connect to the new units, the battle units, item handler signals. If the item is removed for any reason during the combat from the battle unit, we need to connect to a callback method and bind the unit because we need to remove the modifiers or the bonuses that you get from that item, right? And the other thing is when the items change, which can happen when we add new items, right? Then we need to pass in both the unit and the battle unit because we need to keep that synchronized between them. So for that, we need two callback methods. And the other thing that we need to do after copying the unit's items to the new battle unit is to loop through all the items that we have now that we did the copying and apply all the modifiers that we get from those items. That's pretty straightforward stuff, but we need to handle those two callback methods when the items will change or be removed from the battle units. And we do have the callback methods at the bottom. We have onBattleUnitDied. So under this method, we can handle when a battle unit's items change. And what we do in this case is kind of the opposite. We take the battle unit's item handler and copy all the items back to the unit, the original unit, right? Because when these items change, it means that either an item was removed or a new one was added or two items were combined. In any case, I want the unit when the battle is over to reflect those changes, right? So I don't lose the sword I equipped mid-battle. Now, after we've done that, we can redo all the modifiers, right? So we can iterate through the current state of the item handler, remove any lingering modifiers that we had, and apply the new ones. Now here, you could add another line of code, but that really depends on how you want your game to work. What do I mean by that? It might happen that this battle unit change means that you have a new combined item. So if I had a ring on Bjorn, start the battle, equip another ring mid-battle, I don't really want the fireball to launch, right? Because that's kind of cheating. If you say that this bonus effect that you get from stronger items is only present when the item was already on the unit when the combat began, then you should leave the code like this. But if you want your item bonus to be applicable mid-battle as well, so if I 10 seconds in slap 2 rings on Bjorn and I want the fireball to launch, then I also need to add this line of code here, right? Because I need to apply that bonus effect. But again, this would launch the effect twice, right? So this is kind of problematic in a sense because I loop through all the items. So if I already had the ring when the combat began and slapped 2 rings mid-battle, then that would launch 2 fireballs because I loop through all the items that the battle unit currently has. So now Again, this is kind of tricky. If you want this to be more complex for your game or you want to adhere to different rules, feel free to do it. For this demo, I just say that all the bonus effects that you get from stronger items will be applied once at the beginning of the combat. And that's about it for this callback method. And those are the two things that we need when it changes mid-battle. We need to copy the changes over to the unit and redo the modifiers for the battle unit who is currently battling. Now for removing an item is much simpler. We just need to remove the modifiers that the unit had from that item. Removing an item mid-battle can only happen if we combine two items now. So if I had a ring and I get +5, I slap a ring on top of it, I get a RingRing, but the ring will be removed that I originally had. So I removed that 5 flat modifier that I got from it. Right? So again, just to make sure that you get what's new and what's not, we have two new callback methods here when the items on the battle unit change or if they're removed. And we have this new method called addItems, which is called for every unit once when preparing for the combat. And for this one, we do a bunch of things and apply modifiers and connect the signals. And in our prepare fight method, we do call this addItems for every unit, passing in the unit and the battle unit that we spawn. And at the very bottom of the same method, when we turn on the AI for the units, we also apply the bonus effects from the strong combined items once. Whew, okay. So if we save this with Control S, we should be ready to go, and all these bonuses are now hooked up in the game systems. So let's test them first, right? If we go back to 2D view and run the game, I buy a couple robins, buy a Bjorn, slap them in. And equipping 2 rings on Bjorn should get a RingRing, and equipping the gloves on Robin should provide the attack speed boost. Right? So let's start the game. And nothing happens, the fireball hasn't launched yet, but this is because we didn't script that yet, right? Because this apply bonus method is just empty for now. But if you take a look at Robin, well, he doesn't really seem to attack much faster than he usually does, right? Let's see if those modifiers are present or not. So if we go to 2D and select our Robin battle unit, let's go to modifier handler, modifiers, and the attack speed should be the third one. Take a look at this. We have 2 modifiers. One is the gloves, right? And it gives a 10% modifier, which is awesome. And we should have the elf trait as well, which is another 10%. Yeah. So we have that bonus. Now, if we take a look at our Bjorn, if we can find him, modifiers, we should have an AP modifier, right? Which is the 5th one. Yeah. And we have RingRing and 13 is flat. Now we do have the modifiers applied based on the items that we have. Now, if I continue playing the game, go back to game input, just drag that ring over Bjorn again and pause it. Maybe I was too late. Let's see if these are the units or the battle. No, it's still the battle unit. Okay. So the item handler should have a ring on it as well. Oh, but it's snapped back. Okay. So I guess we can't test it without doing it over again, but let's do that then. Let's just play another battle and try to slap this ring on Bjorn again. Okay. Now I did this mid-battle. So if we go back to 2D, select Bjorn, go to the item handler, we should have 2 items. Yep. If we go back to the modifier handler, we should have 2 modifiers now. One from RingRing, which is 13, and one from Ring, which is 5. Okay, so the modifiers kind of work, but we can't really see anything from the AP, like the ability doesn't do more damage. But when we do conclude the battle, if we select Bjorn now, this should be a unit, right? As we have very different components attached to it. And you see the item handler has 2 items. We have the ring, which we equip mid-battle, and we have the RingRing that we already had. Awesome. So the changes came through for the unit, so the synchronization works as well. What doesn't really work is getting any bonus from the AP, right? I think the attack speed was there. So if we stop the game, go back to the script tab, press Ctrl-Alt-O and search for AutoAttackState. I think we already applied the modifiers, right, last time. So what we do have some comments here. But what we do is when we enter the state, we set out the attack timer. And this method takes the modified values into consideration when we conclude the final attack speed. So why do you think that this solution is still not there yet? Well, it's because it does it once when we enter the state. But what happens if the combat starts and I slap the gloves on Robin afterwards? Then the modifier will be added because we have that in the battle handler, but this AutoAttackState does not take it into consideration. So we somehow would need to hook up this AutoAttackState to react to any changes for items mid-battle as well, right? Because I can slap the gloves on Robin, but it won't change the attack speed until we re-enter this state. So it can happen when I kill an enemy as Robin and go to the chase state, chase another enemy, go to the AutoAttackState again, then it will be modified, but I want this to be immediate. When I slap on the item, I want to recalculate the attack speed, right? But see, the cool thing is this will be pretty easy to do. So we have these commented outlines like this one, where we store one modifier, AS modifier, which stands for attack speed. And when we enter the state, we have this line of code here. If we uncomment it, we say that we should grab the actor units modifier handlers, get modifier, and the modifier for the attack speed. Now the cool thing about this is that this modifier changes when we equip new items, and we see that that happens real time, right? When we do the combat. So if we press and hold Ctrl and click on the modifier class, you see the very cool thing about this is that we have a signal when the modifier changes. And you see, if we add a new value, we emit the change signal, and when we remove a value or clear the values, we always emit this changed signal. And this makes it super easy to handle this complicated case because we can just do as modifier.change.connect and just connect the same method that we call once when we set up the attack speed for the unit, right? So whenever the attack speed modifier changes as we are in this state, we call this method that recalculates everything for us. Now this would mean that when we slap an item in game, the auto attack state will represent that change as well. Pretty cool, right? So we needed to do this and this, these two lines of code, and this one to grab this variable reference. Awesome. So we can save this with Control S, and we can test this. But to make it an easy to see difference, I think we should bump up the gloves a bit. So if we search for gloves.trs, double click on it, and let's change the modifier value for the attack speed to something really visible, like, I don't know, 70%. Save it with Control S, and let's play the game. And let's equip, let's not forget to go back to game input and equip a level 1 Robin, just a level 1 Robin. Start fighting, we start shooting. Yeah, slap it in. I don't know, I kind of expected a bit more dramatic difference, but let's make him a level 2 then. See if we can see the difference. So we start battling. Oh, maybe I just didn't equip it. Yeah. Okay. So I'm very bad at this. It didn't get dropped on top of the unit, I believe, because of all the debug things. But if we start again, I can try to equip it. Yeah, now this time. It should shoot much faster, right? You can see that I killed a lot more enemies. And now if I start battling again, the gloves should still be equipped, and you can see how crazily fast he attacks, right? Did that work? Just to make sure again. So this is a Robin without the item. Now let's just die first. See if I can equip it, and now equip it mid-battle. Yeah, it works mid-battle. You can see how crazy fast he starts attacking. Okay, so we needed to make this change to the auto attack state to reflect this. Now for Bjorn, when we equipped the RingRing, there was no real benefit of using the AP. And while we could implement the AP bonus for Bjorn's ability, I just don't really want to spend much time on it because it's very much alike what we did with the auto attack state. So if you take a look at this, we have the auto attack state and we grab the modifier, and when we set up the attack timer, we get the modifier handler's get modified value to make sure that we get that. And when we press Ctrl+O and search for Bjorn swing, it really much would be the same thing. We have the base damage per tier, and we do have access to the caster, right? And the caster is a battle unit, which means that you have access to the modifier handler. You know what, we can do it. Why not do it while we're at it, right? I just kind of want to show you that it works with everything else. You just need to be careful how you set it up. So in this case, we don't really need to care about making it dynamic and connecting to signals like we did with the AutoAttackState, because when we use the ability, that's a one-time thing. So we only care about the current state and the stats and the modifiers of the unit when we call this use method. First, we can just grab the base AP. So you see we have this here, the caster stats ability power that is applied to it, but this is just the base level. So instead of this, we can store this as a variable, so it won't be too long. And we can call it base AP or something like that. And then we can just do caster.modifier handler.get modified value, and the base value will be the base AP we have, and the type will be modifier.type.unit AP. Right? So all the AP that we get from modifiers will be applied to this. And we get a warning that this is a narrowing conversion, because this will return a float value, so we can just round that up. For example, we round I, and we say that we round it to an integer. If for the percentage calculations, we would get half a damage, right? Okay, so if we save this, now the AP will be applied to the Bjorn's swing ability. And if we go back to 2D view, search for the ability, to make it really visible, you'll see 5, 8, and 10 are the base damages. So one Bjorn swing with a RingRing applied should do 18 damage, which is crazy big. It should deal a lot of damage. So now if we run the game and buy some Bjorns, or maybe a level 1 Bjorn will do. Oh, I was really unlucky, I didn't get any rings. So let's rerun the game. Now it's better. So you can do something crazy like adding 2 RingRings, which should pretty much one-shot all the enemies, right? It's like 20 something damage. Let's see if we can get ourselves up to casting a swing. And it instantly deleted all the enemies. Okay, so now that works as well, right? It's that easy to apply the modifiers to these different abilities and projectiles and so on. Now, the one final thing to do is to make sure that the RingRing actually launches a fireball when the combat begins, right? So that's the last step for this episode. Okay, so we want this RingRing item bonus to launch a fireball at a random enemy and do 10 damage, right? Pretty straightforward stuff. Let's create a new projectile for it first. So in this case, the main node will be a projectile node because we already have that system done. And we get this error message that, or warning message that projectiles need to have a hitbox and a visible on-screen modifier 2D. Okay, let's rename it first though and call it RingRing Fireball. Press Ctrl+A, add an animated sprite 2D because we have some frames for this. Select the root node again, add a hitbox. Select the root node again, add a visible on-screen modifier 2D. Now we have that warning message disappear. Let me zoom in a bit. We have one for the hitbox that we need a collision shape. So let's select the hitbox, add the collision shape 2D. And for that, we'll need a rectangle node, or rectangle shape. Yeah, the only warning that we have is for the animated sprite. Since we have no sprite frames for this, it's empty. Let's click on new sprite frames. Click on it. We'll have one animation. Let's call it fly or something like that. We can autoplay it and look for our fireball.png in the file system. And we cannot just drag this here because this will import it as one frame. So we need to delete this. And if you're using the sprite frames resource, you can click on this icon here and look for sprites, effects, and fireball.png. And you don't really have to do anything by hand. You can just say that we have 6 frames horizontally and 1 vertically. And you can just drag and select all of those. Add the 6 frames. Now we can play the animation to test if we like it. I think it's kind of slow, so we can bump up the FPS to like, I kind of like 10. Make sure that looping is enabled when the projectile is flying. And that's about it for the animated sprite. One thing we can do is go to the transform on the node 2D and set rotation to 90 degrees. So the projectile is facing to the right, and collapse this. For the hitbox, I think we can make it much smaller. So select the collision shape and move this in. Yeah, we don't have to have a big hitbox for the fireball. Something like this works fine. Maybe a bit bigger on the X, like this. Also, one thing we can do is for the hitbox, we need to set the correct layer. So let's go to collision, and the layer should be at the enemy layer. But I think this is done from code as well, but just to make sure that it works. And I think since we'll set the damage from code, that's about it. For the fireball, we can save this with Control S, and in our scenes folder, we have a projectiles folder where we have Robin's arrow. We can save this next to it. And we need to create the ability for the spell as well. And we do have a class for that. So, and a bunch of components, just so you can see how easy it is to compose this whole thing. Just to clear things up a bit, I right click on the RingRing fireball and close all the other tabs. Click on the plus sign. This time the root node will be a unit ability. Double click and rename this to RingRing spell. Press Ctrl A and attach an attack node under it. And also press Ctrl A and look for a scene spawner that will spawn the projectile for us. For the scene spawner, we can quick load RingRing fireball. Double click and we can call this fireball spawner. For the attacks spawner, we can assign this node in the export variable. And for the RingRing spell, we need to provide our own custom script that extends the unit ability class. And we do have a template for this. So let's click on the script button here. RingRing spell is fine, but we don't really want to save it to the root folder. So let's click on cancel and press Ctrl S first. And go up a folder, go to abilities, and RingRing spell can lay here. Now click on the attach script button. And RingRing spell.gd is fine, but for the template, we can actually select the custom unit ability script that we already created. Click on create. It will provide this template for us to begin with. Now what we need to do is pretty straightforward. We'll have an export variable for the damage that the fireball does, and an already variable reference to the fireball attack node. And we can set all the export variables for the attack that we didn't set from the inspector, because here we have access to the caster unit, right? The battle unit. So what we can do is we can set the parent to the caster, the anchor to the ranged attacks anchor, and the spawn point to that as well. And then we grab all the possible enemies, right? So we'll get the opposing team, which is in this case, since we'll be the one casting the spell, will be the enemy units. We grab all the enemies and we spawn the projectile, which is a method we are yet to implement, and emit the ability cast finished signal. Now, what does it mean to spawn a projectile? The item description says that it targets a random enemy at the beginning of the combat. So just as a safeguard, if the enemy's array that we pass in is empty, we can return from this method immediately. But if it's not, we need to filter through the enemies, because it might happen that a unit is dead in the same frame that we are trying to cast the ability. In this case, this will be a queue-freed object with the reference still hanging in there, but it's not a valid target anymore, right? Because by the next frame, that node will be nowhere. It will be deleted. So what we do is we use array.filter to filter through all the enemies in that array, all the nodes, and return whether this instance is valid or not. If it's a valid instance, not one being deleted, then we mark it as a valid enemy, a valid target for our fireball. Now, if that filtered list of valid enemies is empty because for some reason all of the enemies are being deleted in the same frame, then we return from this method because we have no valid target for our fireball. But if we do have, then we play the sound effect for the fireball. We'll pick a random enemy with array.pickRandom from the valid enemies and cast it to a battle unit. And we'll call the attack node's attack method and pass in the enemy's global position as a target. And then set the target property to the enemy's global position as well. And set the projectile's hitbox's damage property, which we didn't set in the inspector, to the damage that we provide here in the ability as an export variable. And that's how fast we can come up with new abilities with all the systems that we laid out earlier. We can save this with Ctrl S, go back to the view, And we can just bump up the damage to something like 10. And I believe we don't have any sound effects for this in the project, but you could assign it with quick load here. Yeah, I don't think I have a fireball sound effect, but we could search for one and assign it like this. Let's save everything with Control S. And now we have the spell ready to go, but we still don't have a script for RingRing. It still just calls this apply bonus and does an empty method call, right? So we somehow need to create a script which actually uses this spell on the enemies. And to make it easier to do these kind of scripts, I just do a template for it, like we did with the abilities. So if we clear all the filters we have and close up all the folders, we have our script templates folder, and we can create a new one for item bonuses under node. We have the trade bonus template and the unit ability template. So let's right click on node, since we use this for resources, create a new script and call it item_bonus template. Click on create, double click to open it up in the script editor, and this will be pretty straightforward. We'll provide the metadata. I just called it item script with extra bonus, apply extra bonuses to battle units beside modifiers. We'll generate the class name from the file name, extend the item resource class, and this signals to us that we should override this apply bonus effect method when we want to do something else. And we do have access to the battle unit that is applying that bonus. Awesome, so we can save this with Control S. Ignore that error for the underscore class underscore, this doesn't really matter. And now, just to make sure, I always do a project reload current project to make sure that we have applied those changes. And now we have our script template here. We can actually create that script for RingRing. So I'll go back to data and items, and we have ringring.tres, and now we need the script for it as well. So let's create a new script. I call this ringring.gd, and for the template, I just select our new item script template, click on create. And before we do anything, I always forget to do this, double click on ringring.tres, and you see we have this script icon here that is assigned to it. So let's just replace that with ringring.gd, like so. You see, it signals us that it has its own unique script attached to it, but we get all the same export variables since this extends from item as well. Now we just need to somehow make sure that when we call this method, the fireball gets launched at the enemy. And this is pretty straightforward, but we need a reference to the RingRing spell scene. We can do this as a constant, or we can do this as an export variable, whatever works for us. I just use an export variable now, and we'll call this RingRing spell, and it's a peg scene. When we call this apply bonus effect method, what we'll do is we'll instantiate the ability and cast it to a unit ability. So we get code completion, add it to the root of the scene tree, which we grab from the battle unit reference, set the caster to the battle unit, and connect to the ability cast finish signal to make sure that this ability node itself will be deleted, and call the use method. I use call deferred here to make sure that this will be called at the end of the frame when everything is finished. Because in this use method, if we go back to ringringspell.gd, we do check for valid enemies, right? Not the ones that are being deleted. And if we make sure that we push this to the end of the frame, then Q3 will be already called to enemies that should die on this frame, and the use will be called afterwards, so we can filter through the enemies that are being deleted this way. And that's about it. Everything else is handled in those scripts. We save it with Control S, go back to 2D view, and if we select ringring.tres, we do have to assign, if we use an export variable for this and not a constant, we can just quick load and search for ringringspell.tscn, like so. Phew, okay. That's about it. That should do it. If we save everything with Control S and play the game with F5, add in a tier 2 Robin, create a ring on him, and play the game. Okay, you see that the fireball is spawned there, but for some reason it stays there as well. So maybe that's a bit of a mess up on my side. So let's run the game again and see why the projectile doesn't really fly anywhere. Right, let's do ring again, run the game. And it can happen that for some reason it doesn't have a valid target. Let's see what's going on here. Let's go to 2D and select our ring fireball here. You see that it does have a valid target. You see the problem? The speed is set to 0. So if we speed it up to 200 or something like that and continue the game, you see, it flies and works perfectly fine. I just forgot to set the projectile speed in the inspector. So press Ctrl-Shift-O and search for RingRing Fireball and set the speed to something different than 0, maybe 200. 200 looks fine. Save this with Ctrl-S and run the game one final time. And let's not be an idiot like I am and switch back to game input. Buy a couple of robins, maybe even buy a Bjorn if we can find one. Buy some XP, put in that robin and slap a RingRing on him. So now we should have the fireball flying and damaging a random enemy. Pretty awesome, right? So that's about it for the item milestone of the project. We can already create items, create recipes, add modifiers, provide cool custom bonuses for them, so it's pretty much there. You see that we have an error message which seems quite random. It's called cannot convert argument 1 from object to object. It has to do something with the target reached, and I already got some questions regarding this. I know about the existence of this error, but we'll have a dedicated bug fixing episode at the end of the season, so don't worry about it for now. I just wanted to let you know that I know about the existence of it. Okay, so good job with finishing the items. That's about it for this episode, and I'll see you in the final milestone, which is adding tooltips to the game so we can actually see what these traits do and what items units currently have equipped. I'll see you there. Bye-bye.